Hello everyone, welcome back in Arena World Education. Here we make mathematics easy and interesting. I'm Rajiv Dogra, your mathematics trainer, and today we are going to explore a very important chapter of NCERT mathematics, that is complex numbers. And don't get afraid by the name of this chapter, although name is complex numbers, but it is not complicated. This is very easy, right? And if I talk about this chapter, so this chapter is not only crucial for your school curriculum, it is equally important for all the competitive exams. And I can promise you by the end of this session, you will have complete clarity of complex numbers. So let us start the session. And be ready with your pen and notebook. We will discuss so many important concepts. Before starting the session, this is the important question: why complex numbers were introduced? We have infinite numbers, that is from minus infinity to plus infinity. So then, why complex numbers were introduced? Take a moment and tell me what is the reason. Yes. Yes. So when we study mathematics, we often come across equations like x square plus 1 equal to 0. And if we try to solve this equation, what we will get? We will get x square is equal to minus 1. So now, can you think about a number which when squared gives you minus 1? Take a moment and think about it. Is there any number on the number line from minus infinity to infinity, which when squared, you will get answer as minus 1? Yes, take a moment. There is no real number gives a negative result when it is squared. This means we need a new type of number to handle all such type of cases. So then, yes. So there was introduction of iota. Iota is what? This is an imaginary unit. So mathematicians, so they introduced iota, right? And the value of iota is what? It is under root minus 1. If iota is equal to under root minus 1, so after squaring, what you will get? Iota square will be equal to minus 1. And look at this equation. X square is equal to minus 1. So iota square is minus 1, right? So in place of minus 1, what we can do? We can write iota square. So x square is equal to iota square. And when we have x square is equal to a square, then x will be equal to what? X will be equal to plus minus a. So here, the value of x will be what? X is equal to plus minus iota, right? So this is the reason why complex numbers were introduced. And a complex number is written as, this is a standard notation of complex number, a plus b iota, where a and b are real numbers and iota we had already discussed. This is an imaginary unit. I think you have now complete clarity why complex numbers were introduced. Majority of students, they say, like, what is the benefit of studying complex numbers? Now let me tell you how complex numbers are related with our real life. Strange, complex numbers are helping in our day-to-day life. Yes. So let us take the example of mobile phones and complex numbers, right? So imagine you are talking on a phone with a friend. So then what will happen? Your voice travels as a signal, right? And this signal is what? This is actually a wave. So these signals are what? These are complex numbers. In fact, engineers use complex numbers to process sound, remove noise, and improve signal quality. Without complex numbers, modern Wi-Fi, GPS, and mobile networks, so they wouldn't exist, right? So next time when you call someone or you are watching anything on YouTube, remember complex numbers are working behind the scenes. So in this way, complex numbers are helping us in our day-to-day life, right? So now let us start the session. And these are the objectives of today's session. So by the end of this session, you will be able to define and represent complex numbers. You can easily perform arithmetic operations on complex numbers. So then you will be able to represent complex numbers graphically on Argand plane, right? So just like we had discussed in coordinate geometry as coordinate plane. So to represent complex numbers graphically, we use Argand plane or complex plane. So then we will be able to find modulus and conjugate of a complex number. And at last, we will solve many problems based on complex number. Now let us discuss few key concepts about this chapter and please note down the same. We have already discussed a complex number is a number that can be expressed in the form of x plus iota y. So this is the standard notation of a complex number. Here, if we talk about x, so x is called real part, y is called imaginary part. Together, iota into y. So that is imaginary number, right? So if we talk about iota, we had already discussed this is what? This is an imaginary unit. Always remember, set of complex numbers is a superset for real numbers and imaginary numbers. Whether it is a real number or imaginary number, they are subsets of complex number. Or in other words, we can write all the real numbers or imaginary numbers in the form of complex number. Let us understand how we can do it. This is the standard form of complex number. Z is equal to a plus iota b, right? All real numbers can be written as complex numbers by setting b equal to 0. So b is what? B is the imaginary part. If imaginary part is 0, right? Suppose we are having 2. So 2 is what? 2 is a real number. And how we can write 2 in the form of a plus iota b? It is simply 2 plus iota into 0 or 2 plus 0 into iota, right? Imaginary numbers have the form b iota and can also be written as complex numbers by setting a equal to 0. So let us take the example. We are having 2 iota. So this is what? This is an imaginary number. If we want to write it in the form of complex number, so this will be what? This will be 0 plus 2 iota, right? So here 0 is what? A. So A is real part. So in case of real number, imaginary part is 0. And in case of imaginary number, real part is 0, right? Now let us understand all about iota. Iota we had already discussed. Iota is an imaginary unit and the value of iota is equal to under root minus 1, right? And after squaring, we will get iota square is equal to minus 1. If we take cube of iota, so then we can write iota cube is equal to iota square into iota, right? And iota square is what? It is minus 1. So minus 1 into iota, so it will be simply minus iota. It means the value of iota cube is minus iota. If we want to find iota raised to power 4, we can write iota raised to power 4 is equal to iota square whole raised to power 2, right? And iota square is what? It is -1. So minus 1 square. So that is equal to 1. So iota raised to power 4 is equal to 1. Right? So now if we want to find iota raised to power 5, so that will be what? Iota raised to power 4 into iota. And that will be equal to what? That will be iota raised to power 4 is 1 and this will be iota. Right? So then iota raised to power 6, this will be iota raised to power 5 into iota. And iota raised to power 5 is iota. So directly I'm writing. So this will be what? Iota into iota, iota square. And this will be equal to -1. Right? So this cycle will repeat. Initially, iota was what? It is under root -1. Right? Or simply iota raised to power 1 is iota. Then iota square is -1. Then iota cube is minus iota. Iota raised to power 4, it is equal to 1. Iota raised to power 5, it is again iota. Then iota raised to power 6, -1. Iota raised to power 7, minus iota. Iota raised to power 8, 1. So then again iota raised to power 9, it will be iota. So cyclicity of iota is iota -1 minus iota then 1. Right? So it repeats after this cycle. Whenever we have to find the value of iota raised to power n, n is any real number. Right? So then what we do, we will divide n by 4. Right? If remainder is 0, so then iota raised to power n will be 1. If remainder is 1, so then iota raised to power n will be equal to iota. If remainder is 2, then iota raised to power n will be -1. And if remainder is 3, then iota raised to power n will be equal to minus iota. Right? So let us solve these two questions. Look at this one, iota raised to power 20,296, which is a very big number, right? But don't afraid, whenever we have to solve questions related to iota raised to power some n number. So what we do, we divide power by 4. So here power of iota is 20,296. So simply we check 96. If we divide 96 by 4, it is completely divisible by 4. Right? So it is what? It is 24. So 24 fours are 96. So remainder is 0. So if remainder is 0, so then answer will be what? 1. So here in fraction of seconds, you can solve iota raised to power 20,296. Answer will be 1. Now let us try second question. Iota raised to power minus 3,927. Always remember, whenever we see any question of the type iota raised to power minus n. So first of all, we will write it in the form of 1 upon iota raised to power n. Right? So this will be what? This will be 1 upon iota raised to power 3,927. Right? So then same process. 3,927. So we will divide this exponent by 4. So we will consider last two digits. So 27. So if we divide 27 by 4, so remainder is what? Remainder will be 3. It means this iota raised to power 3927. This is equal to what? Minus iota. So this will be equal to 1 upon minus iota. But you know, the standard form of a complex number is a plus iota b. We cannot leave this question at this stage 1 upon minus iota. In fact, what we will do, we will multiply and divide this 1 upon minus iota by iota. Right? So then 1 into iota is iota. and minus of iota square. Iota square we had already calculated, it is -1. So minus into minus, it will be plus, right? So here you will get this whole iota raised to power minus 3927 equal to iota, right? So in this way, if you know about the powers of iota, you can solve all these questions in fraction of seconds. I hope everybody is clear. Now let us discuss about algebra of complex numbers. Means how to add, subtract, multiply or divide two complex numbers. So we have first complex number is a plus b iota and second is c plus d iota. So in case of adding, what we will do, we will write the like terms together. So here a and c, these are what? These are the real parts. So a plus c will be together and b iota and d iota. So these are what? These are imaginary numbers. So here b plus d into iota. So here this is the standard form of what? Complex number x plus iota y, where x is what? A plus c, which is the real part, and y is b plus d, this is the imaginary part, right? Similarly, if we have to subtract two complex numbers, so the same process we follow, we will combine real parts. So a minus c plus b minus d, right? When it comes to multiplication, always remember a plus b iota into c plus d iota. Here we will use iota square and that is equal to -1, right? You can check this one. If we multiply a plus b iota and c plus d iota, so here this will be what? A into c plus d iota and this will be b iota into c plus d iota. So now this will be what? AC and this will be a into d iota plus bc iota plus b into d and this is iota square, right? Iota square is what? -1. We can write AC and BD together. So it will be AC minus BD, right? And here this AD plus BC will be inside the bracket and iota will be outside. So here AC minus BD, this is the real part and AD plus BC is the imaginary part, right? So fourth one is what? Dividing two complex numbers. So A plus B iota divided by C plus D iota. Always remember the standard form was what? Z is equal to X plus iota Y. So here A plus B iota and C plus D iota. So what we will do? We will multiply numerator and denominator by C minus D iota, right? And simply we will multiply numerator and denominator and we express numerator in the form of this one, just like we had already discussed how to multiply. And at last, we will write this in the form of x plus iota y. You will get division of two complex numbers. I hope everybody is clear. Now let us understand about Argand or complex plane. It is similar, just like we were discussing coordinate plane in coordinate geometry, right? But the only difference is x-axis are treated as real axis and y-axis are treated as imaginary axis, right? So a complex number is what? It is of the form z is equal to a plus iota b. And in Argand plane, a point is represented as a comma b. A is what? A is the real part and b is the imaginary part. right? Suppose we have to represent 3 plus 2 iota. 3 plus 2 iota. So here, if we talk about Argand plane, that quadrants are same. This is the first quadrant, second quadrant, then it will be third quadrant, it will be fourth quadrant. In first quadrant, both are positive. In second quadrant, yes, x is negative, but y is positive. In third quadrant, both are negative. In fourth quadrant, x will be positive, but y will be negative. So if we have to represent 3 plus 2 iota, a complex number in this Argand plane, so what we will see, this is the value of A and this is the value of B. So simply we will find point having coordinate 3, 2 will be in which quadrant? Both are what? Both are positive. So it will be in first quadrant, right? When we are having minus 4 plus 3 iota, means we will represent minus 4 comma 3. So it will be in second quadrant. You can see minus 2 minus 3 iota. So representing minus 2 comma minus 3. So this will be in what? Third quadrant. You can take example of fourth quadrant as well. Suppose you are having 3 minus 4 iota. So here, this point will be what? 3 comma minus 4. And this will be in fourth quadrant, right? So this is all about Argand or complex plane. How we can represent a complex number in Argand plane, right? So next one is modulus of complex numbers. What is modulus of a complex number? It is distance from the origin on the Argand plane. So origin is what? Origin is same 0, 0. And if we take any point as P and having coordinates A, comma B, you know how we find the distance between 2 points. Suppose A and B are 2 points. So B is what? X2, Y2. And A is X1, Y1. So the distance between A and B. So that will be what? That will be the, yes, what is the formula? It will be x2 minus x1 whole square plus y2 minus y1 whole square whole under root, right? So if we solve 0, 0 and AB, so the distance between this origin OP, so this will be what? This will be equal to under root A square plus B square. So modulus of complex number, this is the sign of mod Z. So mod Z is equal to under root A square plus B square. So this is called modulus of complex number. So note down this one. This is very, very important. Whenever we will find modulus of complex number, so we will directly use this result. Now let us discuss about conjugate of complex number. Conjugate of a complex number is what? It is its reflection across the real axis on this Argand plane, right? So if we talk about a point z is equal to a plus iota b, right? So it's reflection. So reflection across the real axis. So how we find the reflection? Look at this one. From real axis, this point is what? Suppose this is P, right? So this point is B units away, right? So in case of reflection, size and shape of the object, so that will be same, right? So what we will do, from P to x-axis, distance is B. So from here, the reflection, suppose this is the P dash, right? So here at this point, distance will be same, right? So we will place this new point exactly B units away from real axis, right? So here x point will be same. Suppose this is what? This is A comma B. So this will be what? This will be A comma minus B. Why A comma minus B? Because this is in fourth quadrant, and in fourth quadrant, y coordinate is negative, right? So whenever we have to find conjugate of complex number, suppose original number is a plus b iota. So what we will do, we will just change the sign of what? Imaginary part. So a plus b iota, its conjugate will be a minus b iota. And if original number is a minus b iota, so then yes, so we will change the sign of what? Imaginary part. So then it will be a plus b iota. So in this way, we can find the conjugate of complex numbers. Next one is multiplicative inverse of complex number. Always remember, when a number is multiplied by its own multiplicative inverse, the resultant value is equal to 1. Right? So multiplicative inverse is what? If we talk about multiplicative inverse of a complex number z, it is simply 1 upon z. Because when z is multiplied by 1 upon z, answer will be 1. Right? So multiplicative inverse is represented by z inverse. Right? So z inverse is equal to what? It is, this was what? This was conjugate. Always remember, whenever you will see this sign, this is conjugate. And whenever you will see this one, this is modulus of complex number. Right? Let us understand why this like formula z inverse is equal to, yes, conjugate of z divided by modulus z square. So we know z is equal to what? Z is equal to a plus iota b, right? So when we find multiplicative inverse, we write z as 1 upon z. So 1 upon z will be what? It will be a plus iota b, right? So always remember, when we find multiplicative inverse, first of all, we write the complex number as 1 divided by given complex number. So here we have taken complex number as a plus iota b, and 1 upon z will be 1 upon a plus iota b, right? What will be the next step? Multiply and divide the number by the conjugate of complex number. So what is the conjugate of a plus iota b? Yes, it will be simply a minus iota b, and the second step was we are multiplying and dividing it by conjugate of complex number. Now simply what we will do, we will, yes, we will multiply numerators. So 1 into a minus iota b, it is a minus iota b. And here a plus iota b into a minus iota b, we will apply a square minus iota b whole square. And directly I'm writing it will be what? A square plus b square, right? So a minus iota b is what? This was conjugate of z. So it is conjugate z, and we had already discussed in previous slide, whenever we have to find the modulus. So modulus was what? Modulus was, yes, it was under root a square plus b square. And if we square both sides, we will get what? A square plus b square. So this will be what? This will be. So that is the reason why multiplicative inverse will be equal to, yes, conjugate z divided by square of modulus z, right? Now it's the time for practice. Now let us solve few questions together. So this is your first question. Express the given complex number in the form of a plus iota b. So what we will do, here we will multiply 5 iota with minus 3 upon 5 iota, right? So this is very easy. Initially what we will see, we will multiplying plus 5 with minus 3 upon 5. So plus into minus, sign will be negative, right? And 5 into 3 upon 5. Yes, 5 into 3 upon 5, 5 will be cancelled out. So we are left with 3 only. Then iota into iota, it will be iota square, right? So we had already discussed what is the value of iota. Yes, very good. Iota is equal to under root minus 1. And what will be iota square? It will be minus 1. So here, what will be the final answer? Minus 3 into minus 1. So that will be 3, right? But according to question, we have to write the result in the form of a plus iota b. So 3 will be written as 3 plus iota into 0, right? So here, if you compare this with standard form, so a will be equal to 3 and b will be equal to 0. So this is what? This is purely a real number, right? There is no imaginary part in this question. Let us solve question number 2. So in this question, we have to again express the given number in the form of a plus iota b. But now you can see we are having iota raised to power 9 plus iota raised to power 19. For your convenience, I have written this rule. Whenever we have higher exponent, so what we do, we divide n by 4. So look at, now if we see this question, so iota raised to power 9. So 9 is not the multiple of 4. But we can write iota raised to power 9 as iota raised to power 8 into iota raised to power 1. Because we are having one rule, x raised to power m plus n, that can be written as x raised to power m into x raised to power n, right? So 9 can be written as 8 iota raised to power 8 into iota raised to power 1. So iota raised to power 9 can be written as iota raised to power 8 into iota raised to power 1. Similarly, iota raised to power 19, so that can be written as iota raised to power 16 into iota raised to power 3, right? So here I have divided 9 in 8 plus 1 and 19 as 16 plus 1 because we will divide power by 4. So these 8 and 16, they will be completely divisible by 4, right? So now look at this one. If we divide iota raised to power n by 4, so then if remainder is 0, then the value will be 1. So here iota raised to power 8. If you divide 8 by 4, so remainder will be 0. So here this part, so this will be 1. Iota will be as it is plus iota raised to power 16, again it will be 1. If you divide iota raised to power 3, 3 by 4. So 3 is not divisible by 4. 3 will be as it is, like remainder is 3. So in this case, you will get iota raised to power n equal to minus iota. So this iota raised to power cube will be minus iota. So let us simplify this one. So this will be 1 into iota and 1 into minus iota, it will be minus iota. So this will be equal to 0. Right? So if we want to write it in the standard form, so 0 can be written as what? 0 plus iota into 0. Here, real part, if we compare this with a plus b iota, so a is 0 and b is also 0. Right? So here, real part is also 0 and imaginary part is also 0. Right? So let us discuss question number 3. Again in this question, just like previous questions, so here iota raised to power minus 39 is given. The only difference is here exponent is negative. So what we will do, first of all, we will write it in the form of 1 upon iota raised to power 39 because x raised to power minus m. So that can be written as 1 upon x raised to power m. Right? So now what we will do, you can see the rule iota raised to power 39. So what we will do, we will break iota raised to power 39 in iota raised to power 36 into iota raised to power 3. Why 36 and 3? Because 36 is the multiple of 4, right? So now iota raised to power 36. If 36 is divided by 4, remainder is 0. It means this part, iota raised to power 36. So this will be what? This will be 1 only. And iota raised to power 3, remainder will be 3. It is not divisible by 4. So if remainder is 3, it will be minus iota, right? So this will be what? This will be minus 1 upon iota. But standard form of a complex number is a plus iota b. So what we will do? We will do the rationalization, right? So here you can see in numerator we are having minus 1 into iota. So that will be minus iota. But in denominator we are having iota into iota. So that is iota square. And iota square is what? Iota square is minus 1. So this will be solved in minus iota upon minus 1. So that will be simply iota. And if you want to write iota in the form of a plus b iota, so this can be written as 0 plus iota into 1. Right? So here a will be 0 and b will be equal to 1. Right? So this is what? This is purely imaginary number. Because here real part a is equal to 0 and we are having only imaginary part. I hope everybody is clear. Let us move to question number 4. So first of all, 3 into 7, that will be 21. And 3 into iota into 7, that will be 21 iota. Plus 7 into iota, that is 7 iota. Plus iota into 7. So that will be what? 7 iota square, right? So in next step, 21 plus 21 iota plus 7 iota, these are like terms. So this will be 28 iota plus 7 into iota square is what? This is minus 1, right? So 21 plus 28 iota minus 7. 21 minus 7, this will be 14 plus 28 iota. And this is the required standard form, a plus iota b. And if you want to find the value of a will be 14 and b will be equal to 28, right? So in this way, we can write the given complex number in standard form. Let us move to question number 5. Express the given complex number in the form of a plus iota b, just like previous question. So what will be the first step? 1 minus iota. This will be as it is. Now you have to be very, very careful. Outside the bracket, we are having minus sign. It means it is minus 1, right? Outside the bracket. So minus 1 into minus 1. This will be what? This will be plus 1. And minus into plus, this will be minus and this will be 1 into 6 iota. It is 6 iota. Now what we will do? We will combine the like terms. 1 plus 1 is 2 and minus iota minus 6 iota, that will be minus 7 iota. In this way, we can write given complex number in its standard form, 2 minus 7 iota. And here, if you check a is 2 and b is minus 7, right? Now question number 6. Express the given complex number in the form of a plus iota b. So here we have to solve fractions, right? So let us open this bracket. 1 upon 5 plus iota into 2 upon 5 minus 4, and minus into plus, it will be minus and it will be what? Iota 5 by 2. right? So now what we will do, we will write the like terms together. So 1 upon 5 minus 4 plus iota into 2 upon 5, right? Minus 5 upon 2. So if we take the LCM, so directly I'm writing 5 into 4, this will be minus 20. So 1 minus 20, it will be minus 19 upon 5, right? If we see this one, 2 twos are 4 minus 5 fives are 25, right? So 4 minus 25, this will give us minus, yes, iota into 21 upon 10, right? So here we will get minus 19 upon 5 minus iota into 21 upon 10, and which is in the form of a plus iota b. If you want to write value of a and b, so a will be minus 19 upon 5 and b will be minus 21 upon 10. Let us move to question number 7. In question number 7, this is similar question of question number 6, right? But here we have to solve 3 binomials. So first of all, let us open the bracket. 1 upon 3 plus iota into 7 by 3. We can write it as iota into 7 by 3 or 7 by 3 iota plus 4 plus 1 upon 3 iota. Now minus. So minus into minus, this will be plus 4 upon 3. And minus into plus, this will be minus iota. Now we will combine the like terms. So this will be what? 1 upon 3 plus 4 plus 4 upon 3, right? Plus iota will be common and we are left with 7 upon 3 plus 1 upon 3 minus 1, right? So if we solve these three fractions, so we will get what? 3 fours are, I'm directly writing, you are in class 11, so I think everybody knows how to take LCM. So this will be 3 fours are 12, 12 plus 1 13, and 13 plus 4 17. So 17 upon 3 plus, look at this one, 7 plus 1 8, and 8 minus 3, this will be 5. So iota into 5 upon 3. And this is the required form, a plus iota b, right? If you want to write value of a and b, so a will be 17 upon 3 and b will be 5 upon 3, right? So let us move to question number 8. Now in question number 8, so we have to again like express the given number in the form of a plus iota b, but this time we have 1 minus iota raised to power 4, right? So we had already discussed x raised to power mn. So that can be written as x raised to power m whole raised to power n. So we can write it as 1 minus iota square, right? And this will be what? Raised to power 2. So inside the bracket, you can see 1 minus iota whole square. So this is a minus b whole square. So we will apply the formula. So this will be what? 1 square. So that will be 1 minus 2 into 1 into iota. So that will be minus 2 iota. Then plus iota square, right? And whole raised to power 2. Iota square is what? Iota square is equal to minus 1. So it will be what? 1 minus 2 iota minus 1 whole raised to power 2. So 1 minus 1, that is gone. So we are left with what? Minus 2 iota whole square, right? So minus into minus, this will be plus, and 2 2s are 4, and it is iota square. And iota square is what? It is minus 1. So this will be reduced to minus 4. If you want to write it in the form of a plus b iota, so minus 4 will be what? Minus 4 can be written as minus 4 plus iota into 0. Right? Here a is what? A is minus 4 and b is 0. Right? Imaginary part is 0. It means this is a purely real number. Right? I hope everybody is clear. Now we are moving to question number 9. Here, the given complex number is what? 1 upon 3 plus 3 iota whole raised to power 3. Right? So I have written the formula. You should remember this formula, a plus b whole cube. So that will be a cube plus b cube plus 3ab into a plus b. Here a is 1 upon 3 and b is 3 iota. So let us apply this formula. 1 upon 3 cube plus 3 iota cube plus 3 into what is a? A is 1 by 3 into b. This is 3 iota and this will be inside this 1 by 3 plus 3 iota. Yes. So this will be what? 1 upon 3 whole cube. So this will be 1 upon 27, right? Plus 3 3s are 9 3s are 27 plus 27 iota cube. Now 3 and 3 are gone. We are left with what? Now directly I'm multiplying 3 iota into 1 by 3. It will be simply iota. And what about this one? 3 iota into 3 iota. So that will be 9 iota square. Right? So now if we talk about iota cube, right? So if we divide it by 4, so then remainder is 3. If remainder is 3, so then iota raised to power n. So that will be minus iota. It means the value of this iota cube. So that will be minus iota. So I will write minus 27 iota, right? Plus iota is already there and iota square is what? It is minus 1. So 9 into minus 1. So that will be minus 9. So next step, we will write like terms together. So 1 upon 27 minus 9 and this is minus 27 iota plus iota. So that will be minus 26 iota. If we solve this fraction 1 upon 27 minus 9, so you will get what? Minus 242 divided by 27 minus iota into 26, and which is the required standard form. Here a will be what? A will be minus 242 divided by 27. And what is the value of b? Yes, b will be, you can write it in this way, b will be minus 26, right? I hope everybody is clear. So in this way we can solve question number 9. Now let us solve question number 10. Just like previous question, again we are having raised to power 3. Now I will recommend stop this video at this point and try yourself, right? So then you can match your answer. This is just like previous question. So directly we can apply the formula. Here, don't get confused if you compare this with a plus b. So A is what? A is minus 2 and B is equal to minus 1 upon 3 iota, right? So first step will be minus 2 cube plus minus 1 upon 3 iota cube plus 3 into minus 2 into minus 1 upon 3 iota, and inside the bracket we are having same minus 2 minus 1 upon 3 iota, right? So let us open these brackets. So minus 2 into minus 2 into minus 2, negative raised to power odd, result is always negative, and 2 raised to power 3, it will be 8. Here it will be again negative raised to power odd number, so this will be again negative, and this will be what? 1 upon 27 iota cube, right? So now next step, 3 and 3 are gone, minus minus plus, and plus iota is plus 2 iota is here, right? So 2 iota into minus iota, so that will be minus 4 iota. 2 iota into minus 1 upon 3 iota, so this will be minus 2 upon 3 iota square, right? So now minus 8 minus 1 upon 27, iota cube is what? Minus iota. So this will be minus minus plus, plus 1 upon 27 iota minus 4 iota. Iota square is minus 1. So we can write it directly 2 by 3. So if we combine the like terms, so minus 8 plus 2 upon 3 plus iota into 1 upon 27 minus 4. This will be minus 24 plus 2. That will be minus 22 upon 3. This will be 1 upon 27 minus 4. So 1 minus 4 into 27. Right? So this will be what? 1 minus 108. So this will be minus 107 divided by 20. Right? This is 27. And here we are having, if you write plus, so plus iota into minus 1 upon 107 divided by 27. If you want to write this, the value of A, so A will be minus 22 upon 3 and B will be minus 107 upon 27. So you can solve question number 10. Now question number 11. Find the multiplicative inverse of given complex number. So in this question, we have to find the multiplicative inverse. And we had already discussed how to find multiplicative inverse. It is what? Conjugate of Z. If we have to find the inverse of Z. If we have to find the inverse of Z, where Z is equal to A plus iota B, then Z inverse will be what? First of all, we have to find its conjugate. So then we will divide it by square of modulus of this complex number, right? So first of all, what we will do, this is what? This is the given complex number. So its conjugate is very easy. So conjugate, so minus 3, it will be what? Plus 3, right? So this will be 4 plus 3 iota. Now coming to modulus Z. Modulus Z was what? When we have A plus iota B, I'm writing the formula. Modulus Z will be what? Modulus Z will be A square plus B square. Means we are finding real part. So square of real part plus square of imaginary part. Then whole under root. So here you can see A is what? A is 4. So this will be 4 square plus minus 3 square, right? So this will be what? This will be 16 plus 9, and this is equal to root 25, which is equal to 5, right? We need z square. So this will be 25. So now finally you can find inverse. So that will be what? Conjugate of z was 4 plus 3 iota, and modulus z square, it was 25. And if we want to write it in standard form, so this will be 4 upon 25 plus 3 upon 25 iota. And this is the required answer for question number 11. Or you can say this is the multiplicative inverse of 4 minus 3 iota, right? So in this way, we can solve question number 11. Let us solve similar question. Now I think you can try root 5 plus 3 iota. So this is z, right? First of all, we will find its conjugate. So yes, conjugate will be, we will just change the sign of this imaginary part. So it is plus 3, so this will be minus 3, right? Now coming to next part, it is modulus z. Modulus z is what? It will be under root 5 square plus minus 3 square, right? So this will be what? This will be 5, and minus 3 into minus 3, this will be 9. So this will be a root 14, right? What we need? Square of modulus z. So this will be what? Root 14 square. So this will be equal to 14. Now z inverse is equal to conjugate of z, that is under root 5 minus 3 iota divided by square of modulus z. So that is equal to 14. So what is the final answer? It is under root 5 upon 14 minus 3 upon 14 iota. So in this way, we can solve question number 12. Question number 13 is same just like 11 or 12. The only difference is this is purely imaginary number, right? So don't get confused. For your convenience, you can write it as 0 minus iota, right? Z is equal to what? 0 minus iota, right? So what is the conjugate of this number? This will be what? 0 will be as it is, but minus iota will be plus iota, right? So now what is the next step? We have to find its modulus. And if we compare this with a plus b iota, so here a is 0, but b is what? B is minus 1, right? So what is the modulus? It will be 0 square, so that is 0 plus minus 1 square, right? So this will be what? 0 plus 1, and under root 1 will be 1 only. If you find its square, so that is again 1. So directly we can write z inverse. So that will be what? That will be, yes, conjugate. It is 0 plus iota, and what is the modulus z? It is 1, and we need 1 square. So final answer is iota only. So z inverse is iota, right? If you want to write it in the standard form, this is 0 plus 1 into iota, right? So in this way, you can solve question number 13. Now question number 14. Express the given expression in the form of a plus iota b. You can see here numerator is 3 plus iota under root 5 into 3 minus iota under root 5. So we will apply this formula a plus b into a minus b, and that is equal to a square minus b square. Here it will be what? 3 square minus iota under root 5 square, right? Don't forget, value of b will be iota under root 5, right? And you can see denominator. So here root 3 plus iota root 2. And you can see inside the bracket, we are having negative sign. So in excitement, don't consider it a plus b into a minus b, just like numerator. So here you just have to open the bracket. Root 3 plus iota root 2 minus root 3 minus into minus plus iota root 2, right? So this will be what? 3 3s are 9 minus this will be under root 5 square, this will be 5, and 5 iota square divided by, you can see root 3 and minus root 3, this is gone, and you are left with 2 under root 2 iota, because iota root 2 and iota root 2. So this will be 2 times under root 2 iota, right? So we know iota square is what? This is minus 1. So you can see numerator will be minus 5, 9 minus 5 into minus 1 divided by 2 root 2, right? So you can see in denominator we are having iota. We are multiplying this with iota and dividing by iota to remove this iota, because we want to write it in the form of a plus iota b. So now you can see minus 5 into minus 1. So this will be 9 plus 5, 14. So this will be 14 iota divided by iota into iota, iota square. So directly I am writing minus 2 under root 2. This will be equal to minus 7 upon root 2 iota, right? You can leave this question at this moment. Otherwise, to remove this under root 2 from denominator, we will rationalize this one. So we are multiplying and dividing this by under root 2, right? So this will be what? This will be minus 7, and under root 2 into under root 2, this will be 2, right? And this will be under root 2 into iota. So final answer is minus 7 upon 2 under root 2 iota. But we want to write it in the form of a plus iota b, and here real part is 0. So what we can do, we can write it as 0 plus iota into minus 7 upon 2 root 2, right? So final answer is 0 plus iota into minus 7 upon 2 under root 2. So in this way, you can solve question number 14. So this is all about today's session. If you have enjoyed this session, so then hit the like button and share it with your friends. And for any type of query or suggestion, you can use the comment section. For more interesting videos, subscribe Arena World Education, and thank you very much. See you again in the next session.